Are you an S4 student, a vacist, or even then an all-level teacher? Welcome to this episode, Digital Science for You. I'm Nicholas Norbert. Digital Science and Virtual Lab. You could ask yourself, what is that all about? Well, Digital Science and Virtual Lab is a student learning easily and a teacher teaching with no hassle. Digital Science and Virtual Lab software is a whole all-level science and mathematics curriculum presented in a digitized format. A mixture of 2D, 3D, video animation with text and sound. How it works, all you need is a computer with software and you, the student, and we are ready to roll. One of the reasons why it's almost impossible to carry out an experiment of how to make chlorine gas, well, it's because it is a very poisonous gas. If you came in contact with it, the effect would be hazardous. That is why every teacher comes out to tell you it's impossible to carry out that experiment in a classroom. But in this lesson today, a teacher using digital science and virtual lab gets you closer to chlorine.
Hello class, my name is Naboth. Today I'm your chemistry teacher. Today we're going to look at a senior 4 topic called chlorine. As you can remember from your senior 2 chemistry, chlorine is a poisonous gas, and in your schools, teachers don't teach it practically because they don't want to expose students to its poisonous nature. But today, I'm going to teach you this topic using digital science that is going to show us how it is prepared in the laboratory. So, we go to senior 4, digital science, chemistry, and then we choose a topic, chlorine, and then subtopics, laboratory preparation of chlorine, and then physical and chemical properties, and we click on show. This is the setup of the apparatus for preparation of chlorine. I'm going to take it back at the beginning, so we'll look at the reagents required. So we have a thistle funnel in which we put concentrated hydrochloric acid. Then we also have potassium permanganate crystals, which we put in the round bottom flask. We have the 2 conical flasks. One we put water, another one we put concentrated sulfuric acid, and then we also have a gas jar used for collecting the gas. All the flasks must be at the same level because they are put on the table. And then we will now play and we see concentrated hydrochloric acid is put in the thistle funnel and it runs into the flask and it reacts with potassium permanganate crystals. There we get a gas. The gas is bubbled through water, which removes any traces of hydrogen chloride that may move along with the chlorine gas. Then it is passed through concentrated sulfuric acid for drying, and then the gas is bubbled through, is received in a gas jar by downward delivery because it is denser than air. A point of emphasis, when we are arranging this apparatus, we make sure that the thistle funnel is in touch with the acid, and then in the water, the delivery tube must be in touch with the dipped in the water so that the gas is the gas, when it is coming out, all the hydrogen chloride is removed. Then the same thing, the delivery tube must be dipped in concentrated sulfuric acid so that the gas is dried. Now, I wanted to emphasize also on the equation for the reaction. We can see our reactants, potassium permanganate, which is in solid state, reacting with hydrochloric acid, which should be in aqueous state, giving us potassium chloride, which remains in the flask, around bottom flask. Also potassium, manganese 2 chloride, which remains in the flask. Then water, which we have to dry using concentrated sulfuric acid, and then chlorine, which we have now collected in the gas jar. Now, having looked at this, we have now to emphasize and look at the properties of chlorine gas. Remember, all the gases that have been prepared in your class have been colorless. But today, we see that chlorine is not colorless, but it is a greenish yellow gas. Wonderful. You cannot see this in school since we don't prepare the gas, but digital science can show you the gas. Isn't it wonderful? So, after looking at the physical properties of chlorine gas, let's look at chemical properties of chlorine. One, reaction with hydrogen. So here we have 2 gas jars. One, the upper one has got chlorine, you can see it is green, and then the lower one has got hydrogen, but the 2 gases are separated using a cover clip. So when a cover clip is removed and the setup is exposed to sunlight, the 2 gases react together and will produce hydrogen chloride gas. We can even check in the notes that this, in your textbooks, they tell you that this, in presence of sunlight, chlorine forms hydrogen chloride gas, and this reaction is called a photochemical reaction. Just like we know photosynthesis, photochemical means it takes place in the presence of sunlight. This reaction is very explosive and in sunlight, but does not occur in dark. So our next chemical property, we shall look at reaction with hydrocarbons, and one of them is turpentine. So we get a paper soaked in turpentine and lower it in chlorine gas, and then we play and we see there, you see at the beginning the paper was white, but now it has turned black. This is because during the reaction there is some soot or carbon which is given off, and this is the one which is making the paper black. So during this reaction, hydrogen chloride is also given off. So to confirm that it is hydrogen chloride, we get ammonia solution and we dip there the glass rod, and then we bring it near the gas jar containing, and we see dense white fumes, which confirms that there is hydrogen chloride, as can be shown by the reaction, the equations, there. So turpentine has got a formula C10H16 and reacts with chlorine to form hydrogen chloride. Then we also have 10 moles of carbon, which we saw as a black substance on the paper. And then the hydrogen chloride gas, which was formed, reacts with ammonia, and then you form ammonia chloride, which is the one in form of dense white fumes. Our next property will be how chlorine reacts with potassium bromide. So here, chlorine is bubbled through potassium bromide. We're going to play it again. At the beginning, potassium bromide is colorless. When we bubble chlorine through it, the colorless solution turns reddish brown. And the reddish brown color is due to formation of bromine gas, but because it dissolves in solution, then it gives us a reddish brown solution. This one shows that chlorine is more reactive than bromine, and that's why it displaces it from its solution.
You're You're still watching Digital Science for You. Hope you're learning a thing or two about this lesson. You can also access the programs and the sessions via our main offices in Lugogo via the UMA Showground. You can follow us on Facebook and Twitter, CSTSUG. We'll be right back right after this.